Let us talk about this problem. We have n petrol pumps arranged in a circular manner. In this example, we have 4 petrol pumps. This is first petrol pump, and these petrol pumps are represented using 2 arrays. The first array represents amount of petrol available at a particular petrol pump. So first petrol pump has 4 liters of petrol available. Second petrol pump has 8 liters of petrol. Third petrol pump has 7 liters of petrol. Fourth petrol pump has 4 liters of petrol. The second array represents distance of the next petrol pump from this petrol pump. Distance from first to second petrol pump is 6. Distance from second to third is 5th. Third to fourth is 3rd. And from 4th to 1st, because they are in circular, so this distance is from last to first, is 5 units. Now imagine this circular arrangement and imagine that you have a truck which has infinite capacity. You can fill any amount of petrol in this truck. The truck that you have with you, it consumes 1 unit of petrol to travel 1 unit of distance. So we have a circular arrangement of petrol pumps. We have an infinite capacity truck. Our task is to find out first petrol pump such that if we begin from this petrol pump using the truck that we have with us, we should be able to visit all petrol pumps and we should be able to come back to this petrol pump. If there is a petrol pump, such a petrol pump exists, we need to find first such petrol pump. If there is no such petrol pump, then we need to print -1 or return -1. Let us see this example. We have 4 petrol pumps, right? First, second, third, fourth. First petrol pump has 4 liters of petrol or 4 units of petrol, and distance from first to second is 6. So all these values are shown here in this circle. Now let us one by one try beginning from every petrol pump, because we need to find first such petrol pump. So if I begin my truck from the first petrol pump, I'll see in this question, our assumption is our truck is initially empty. So if I begin from this petrol pump, I'll begin with an empty truck. I'll fill all 4 units of petrol in the truck. And if I begin from here, I'll be able to travel only 4 units of distance. So I'll run out of the petrol. And our task is to find a tour so that we never run out of the petrol and we are able to visit all the petrol pumps in a circular way. So this first petrol pump cannot be our answer. Now let's try second petrol pump. I'll again begin with an empty truck. I'll fill 8 units of petrol in the truck, and distance of next petrol pump is 5 units. So I'll spend or consume 5 units, right, of petrol, and then I'll have 3 units left, and I'll fill 7 units more. So if I'm beginning from here, I'll initially have 8, then I'll consume 5, then I'll add 7, right? Now at this point I have how much petrol left? 10 units. Now at this point I'll again travel 3 units of distance, right? And I'll subtract 3 from it, and then I'll add 4 units of petrol. So at this point, how much petrol I have? I have 10 minus 3 plus 4, 7 plus 4, 11. Now I'll again travel 5 units. So I'll have 11 minus 5. I'll have 6 units of petrol, right? Now from the 6 units, I'll fill 4 units more because I'll come back to the first petrol pump, and so I'll fill 4 units more and I'll have 11 units now. 10 units now. And from these 10 units, I need to travel 6 units of distance more, because I started from here, I should be coming back to here. So I will now consume 6 units, 10 minus 6. And I have 10 units, so I can consume 6 units. So I have positive petrol left and I have come back to the petrol pump from where I started. So this petrol pump is my answer. This is the first such petrol pump. See, these might also be possible answers, also I have not checked, but we need to find first such petrol pump such that if you begin from here, you should be able to come back to this petrol pump without running out of the petrol. So our answer in this particular example is second petrol pump, this one. Let's now see the second example. In this example, we have two petrol pumps. The first petrol pump has 4 units, the second petrol pump has 8 units. Distance from first to second is 5, distance from second to first is 6. Now if I begin from the first petrol pump, I cannot begin, right? Because I'll fill 4 units and I need to consume 5 units, which is distance is more. So I'll begin from the second petrol pump. So if I begin from the second petrol pump, I'll fill 8 units and I'll consume 6 units to go to the next petrol pump. So I'll have 2 units extra, and that next petrol pump I'll fill 4 units more. So I'll have 6 units and I need to consume 5 units to go back to the first petrol pump, to the petrol pump from where we started. So we come back to this petrol pump. So our answer in this example is also second petrol pump, right? Let's now see this example. Here we have 3 petrol pumps. The first petrol pump has 8 units of petrol, 9 units of petrol, 4 units of petrol, 8, 9, 4. Distance of first to second is 5, second to third is 10, third to first is 12. Now if I try all the petrol pumps in this example, I can notice that I'll not be able to travel back to that petrol pump without running out of the petrol. For example, if I begin from here, I have 8 units of petrol. I'll travel 5 units. I'll have 3 units extra. Now I'll have 3 plus 9, 12. I'll consume 10. I'll have 2 units extra. 2 plus 4, 6, but this distance is 12. So I run out of the petrol. If I begin from here, I'll have 9 units of petrol and I needed to travel 10 units. So I cannot begin from here. If I begin from here, I have 4 units of petrol and I need to travel 12. So I cannot begin from here also. So in this example, our answer is -1. Now please pause this video and try to write down a program that takes these two arrays as arguments, and this program should return position of the first petrol pump such that if you begin your truck from this petrol pump, you should be able to travel in a circular way and you should be able to come back to this petrol pump. Let us first talk about a naive solution to solve the problem. In the naive solution, we consider every petrol pump as a starting point. We run a loop from start equal to 0 to n-1. When we consider the current petrol pump as a starting point, we move forward from this petrol pump to other petrol pumps one by one, and we check how much remaining petrol we have. So how do we get the remaining petrol? We subtract the distance of next petrol pump from the petrol of the current petrol pump, right? So this gives us the petrol that you are going to have after you have reached the next petrol pump. And we keep on adding these values in the current petrol. And if current petrol becomes negative at any point, right, then you can't reach the next point. In that case, your current start cannot be the answer. So we break the loop and we try the next start. And if it is not negative, if it is greater than or equal to 0, then we keep on moving ahead. And while moving ahead, if our end reaches the start again, if we come back to the current starting point, then we have made the circular tour. So we return start +1. Why +1? Because we want to return the position, not index. For example, in this array, our start is 1 here, but we are going to return 2 because the position of this petrol pump is 2. Let's now understand this approach, this implementation with this example. We have these petrols and these distances. We start with a start equal to 0. We initialize end as start. We initialize current petrol as 0. And then we compute the current petrol as current petrol plus subtraction of this from this, right? Distance end from petrol end. So we get the value as -2. And this current petrol value is negative, which means from the current start, we cannot lead to a solution. We cannot have a circular tour because we have reached negative petrol value. So we break the loop. And when we break the loop, we try with the next start. Now we try with start equal to 1. We initialize end equal to 1. We initialize current petrol equal to 0. And after this initialization, we run this loop. And inside this loop, what are we going to do? We are going to do current petrol equal to current petrol plus petrol end minus distance end. So we are going to subtract 8 minus 5, right? Start end is our 1. So we are going to add 8 minus 5. So we are going to have the current petrol is 3, which is positive, right? So we are going to move ahead now. So end is going to increment to the next petrol pump. Please note that we increment end in a circular way. We do n plus 1 modulo n, right? So now our end becomes 2. And when n becomes 2, we have these indexes. We use these values and compute the current petrol. Current petrol is again positive. So we move the end ahead. And now end becomes 3. For index 3, we again use these values and we get the current petrol as 6, which is again positive. So we make end equal to 0. And this is where circular increment comes into the picture. After 3, you don't have 4, you have 0. So when your end becomes 0, you again compute the current petrol. And what is current petrol? We use these two values and add the subtraction of these two values. So current petrol becomes 4, right? When current petrol becomes 4, which is again positive, so you are going to increment end and now becomes 1. So you are here, you incremented end and end became 1. And the start is also 1 for this iteration. So end and the start, they are same. So we have come back to the original starting point, the point from where we started. So we return start plus 1. So we return 2 as an answer in this example. Let us now talk about time complexity of the solution. An upper bound on time complexity of the solution is big O of n square, because you are going to consider every petrol pump as a starting point and then you are going to traverse all the petrol pumps one by one, and when you see negative, you are going to start from the next petrol pump. So in the worst case, you will need n square time. Auxiliary space requirement for the solution is big O of 1. Now please pause this video and think of a solution that works in big O of n time. And you can use big O of n extra space first, and then we are going to talk about a solution, the best solution in the end, which is big O of n time, big O of an auxiliary space, and does only one traversal of the array. Let us now talk about a better solution. The idea is to use DQ data structure. We maintain a DQ of current set of petrol pumps that can be visited. What we do is, while current petrol is greater than 0, we keep adding petrol pumps to the end of the queue. And if the current petrol becomes negative, then we start removing petrol pumps from the beginning of the DQ. Let's understand this with this example. Take a look at this. We have 4 petrol pumps with petrols 50, 10, 60, 100 and distances as 30, 20, 110. Now, if we see this example, we can notice that we can get all the petrol pumps visited if we begin from here. So our answer is, start point is 3. Now, how do we get 3 with this DQ approach? We initialize an empty DQ. We initialize the current petrol as 0. We begin from here. We add the first petrol pump to the DQ. So DQ now has 0. And whatever is the current petrol, we update it, right? So we update it as 0 plus 50 minus 30. We get it as 20. So 0 is feasible because current petrol is greater than 0. Now we go to the next petrol pump and we update the current petrol and we add the next petrol pump to the end of the DQ. So current petrol becomes 20 plus 10 minus 20, which is 10. We still have greater than 0 petrol. So we go ahead and add the next petrol pump. And next petrol pump is this one, 60, 100. So when you add this next petrol pump, you notice that your current petrol becomes negative, 10 plus 60 minus 100, which is minus 30. Since current petrol becomes negative, it's not a feasible solution. So what we do is, we start removing petrol pumps from the beginning of the DQ. So we remove 0 now and we update the current petrol because this has been removed. This is starting point. So current petrol that we will have at this point is minus 30 plus 50 minus 30. 50 minus 30 is for this petrol because we have removed this petrol pump. So our current petrol becomes minus 50. And it is still negative. So we remove the next petrol pump from the beginning of DQ. So beginning of DQ is 1. So we remove this petrol pump and we get the current petrol as minus 50, minus 10, minus 20, which is minus 40. It is still negative, so we remove this petrol pump also, and we update the current petrol as minus 40 and corresponding values to this 60 minus 100. So now our current petrol becomes 0, right? So we have a non-negative value. So we add the next petrol pump, we add it to the DQ and update the current petrol pump. So we add this 100 minus 10, our current petrol is 90. Then we add the next of this. Since it is a circular tool, so we are going to consider next as index 0. So we add index 0. So our current petrol becomes 110. Now we add this one. So current petrol becomes 100. These are all there in the DQ. Next we add this one. So we have 3012, our current petrol is 60. And now all the petrol pumps are there in DQ. So this is a feasible solution. We can visit all the petrol pumps. And not only all petrol pumps are there in the DQ, we have the current petrol as positive, non-negative. Because this is important. You need to come back to this petrol pump also from 2. So it has to be non-negative, right? So this is a feasible solution. Our starting point is 0.3, and what we did in this solution, we started with an empty DQ. While the current petrol is greater than or equal to 0, we keep adding petrol pumps to the end of the DQ, and when the current petrol becomes negative, we keep removing petrol pumps from the beginning of DQ while the current petrol is negative. Now let us talk about the time complexity of the solution. In this solution, we add every item at most to the DQ and we remove an item at most once from the DQ, right? So every item is added right at the end and removed from the beginning. We never remove an item twice or add an item twice, more than one. So overall time complexity is big O of n, because adding an item is also big O of one operation, removing an item is also big O of one operation, and it requires big O of n auxiliary space. Now please pause this video and think of a solution that takes big O of n time and requires big O of 1 space. Before we talk about the efficient solution, let's talk few things more about the better solution. The first thing is, in the better solution, we can avoid the use of DQ. We can use our original array as a DQ. We can maintain start and end variables and can optimize the better solution to work in big O of 1 extra space. But still, this better solution requires 2n operations, because in the DQ based solution, what we were doing, we were adding an item to the DQ at most once and removing an item from the DQ at most once. So in the worst case, we need 2n operations. We can further optimize the solution to traverse our array exactly once and have big O of 1 extra space. In fact, the solution, the efficient solution that we are going to write, it's going to be very simple single traversal solution. The idea of this efficient solution is based on this fact. If we traverse all the petrol pumps from P0 to Pn-1, and suppose while traversing, we come to a point Pi, where I is the ith petrol pump, and please note that here petrol pump means two values, right? Petrol and distance. So while we are traversing from P0 to Pi, we are maintaining the current petrol like we did in the naive solution. And when we come to Pi, say Pi is a point when your current petrol becomes negative. What we are claiming here is, if current petrol becomes negative at Pi, then none of the points, none of the petrol pumps from P0 to Pi can be a valid solution. Let us now understand the reason behind this claim or this observation. So when we are saying that Pi is the first point when current petrol became negative, what it means is the current petrol must have been positive at all points. So if you take any prefix of this array, right, from P0 to Pi, and if you compute this current petrol from j equal to that prefix index, you will always have positive or 0 value. You will never have a negative value. So current petrol till P0 is positive, current petrol positive or 0, current petrol till P1 is positive is 0, and till Pi-1 also it's positive is 0. It became negative at Pi. So we can show it by doing a counter example. Say Pk is a point which is a valid point, right? But we are doing a counter example. We are saying that this claim is not true and say Pk can be a valid point. Now we are going to show why PK cannot be a valid point. See, before PI everything was positive, so everything must be positive before PK also, because PK is before PI. So current petrol must be positive at this point. Now it became negative at PI. So what are we doing when we are considering PK as our valid answer? This current petrol at PI should also be positive. But what we have done here is we have actually subtracted a positive value from this current petrol. We have removed P0 to PKI minus 1. So you are removing a positive value from a negative value, so it cannot become positive, right? So PI must be negative if you choose PK as a starting point. So none of the points before PI can be a starting point. We can always safely pick I plus 1 as next start point whenever we see a negative value of current petrol. Let us now talk about implementation of the efficient approach. You can notice this implementation. We have a simple traversal of our petrol and distance arrays from 0 to n minus 1, and then we have simple return statement. It's a very simple implementation. And it uses the same idea. We traverse the arrays from 0 to n minus 1. We compute the current petrol using the same way as we did in the naive approach. Petrol I minus distance I is added to the current petrol. Now if the current petrol becomes negative, here we are setting the start equal to I plus 1. So we're using this concept. If current petrol becomes negative, then none of the petrol pumps from 0 to I can be your answer. So you can safely make start equal to I plus 1. And then we make current petrol equal to 0, right? So this is the same thing we discussed. Apart from this thing, you will notice one more thing here in this implementation, which is previous petrol. We initialize the previous petrol as 0 here. We update the previous petrol when we have current petrol as negative. And at the end, we are checking if current petrol plus previous petrol are greater than 0. Sum of these two is greater than 0, then only greater than equal to 0, then only we return start plus 1. Now what is the idea behind this previous petrol? Let's understand this with this example. Say you have these petrol pumps and PI is the first petrol pump after which your current petrol became negative. Then you switched to I plus 1. So when you're switching from PI to PI plus 1, and it's a circular array, right? So you would need the amount of petrol that you need to reach from P0 to PI plus 1. And then you would need the amount of petrol that you need from PI to P0, right? And this is what we actually store in our previous petrol. So the idea is we have already computed this petrol when we are at index I. See, the current petrol at index I means the amount of petrol that you need to reach from current starting point to the petrol pump I plus 1. That's the amount, that's the value which is indicated by the current petrol. And this would be negative. That's why you came inside. So you store this negative value in the previous petrol. So you have this traversal petrol. Then you compute the petrol required to reach P0 from PI plus 1. That you compute by doing the further traversals of the loop. So say it became negative at PI, then you keep on updating the current petrol and it never became negative, right? So it always was positive. You reached at Pn minus 1. So when you reach Pn minus 1, your current petrol is amount of petrol you need to reach P0. Please note that in current petrol, we subtract distance I, which means we are considering that we have reached the next petrol pump, right? So at PI, we subtract distance I, which means we are reducing the distance from PI to PI plus 1. That's the amount of petrol to reach PI plus 1. So when we traverse till n minus 1, it indicates the amount of petrol you need to reach P0 from the current starting point. So what we do is we add this previous petrol and this current petrol at the end. This is actually current petrol. In this example, I am assuming that our start remains 0. It got never changed. There was only 1 point I when we became negative, right? There could be more than 1 point, but for simplicity, I'm assuming simple 1 point. right? So here it became negative. So you have previous petrol and you have current petrol, and you simply added these two and you checked whether it is greater than equal to 0 or not. And since you have come out of the loop, your current petrol must have been positive at all the points except possibly the last point. So you simply check sum of current petrol and previous petrol, and if the sum is greater than equal to 0, your answer is start plus 1. Why start plus 1? Because we want to know the position rather than indexes. So if you see this example, your answer is actually index of position of this item. Index of this item is 3, your answer is 4. Let's now see the working of this idea for this example. So we initialize start as 0, current petrol is 0 and previous petrol is 0. When we run for I equal to 0, we compute the current petrol as 50 minus 30, 20, right? Current petrol, 20 is added to the previous value of current petrol, 0. So 0 plus 20 is 20. Now when we come to I equal to 1, we add 10 minus 20. So we have 20 plus 10 minus 20 is 10. And you can notice that current petrol did not become negative here and here also. When we come to I equal to 2, our current petrol becomes 10 plus 60 minus 100, which is minus 30. So now it becomes negative. And when current petrols become negative, what we do is we set the start equal to I plus 1. So start becomes I plus 1, 3. Previous petrol we store as minus 30. Current petrol we update as 0. And then we go to the next iteration for I equal to 3. And when we come to I equal to 3, we add petrol minus distance to the current petrol. So we have current petrol is 90, which is positive. So we come out of the loop. When we come out of the loop, our current petrol is 90, our previous petrol is minus 30. So sum of these two is greater than equal to 0. So we return start plus 1, which is 4. So this is our answer. We return this. And you can notice that what current petrol and previous petrol mean here is your current petrol became negative at I equal to 2. So previous petrol actually stores this value, right? When it became negative, we stored it into the previous petrol. So your previous petrol is this amount, and your current petrol is from 100 to 50, right? This is your current petrol. And we have simply checked the sum of these two, whether it is positive or not. So this is the idea of the solution. We save lots of computations. We have simple one traversal solution. We are reusing the previous petrol value, and we are avoiding recomputations. Time complexity of the solution is big O of n. Auxiliary space requirement is big O of 1. Please note that better solution also has the same time complexity and same auxiliary space requirement, but this efficient solution finds the answer in one traversal.